Batman, created by Bob Kane and Bill Finger, first appeared in Detective Comics number 27, 85 years ago. And in those 85 years, Batman has accumulated a vast array of vicious rogues, but only one can claim to have left him broken: Bane. So in this episode of Science After Hours, we're going to look at some of the science behind Bane and anabolic steroid abuse. Created by Chuck Dixon, Doug Mensch, Graham Nolan, with additional concepts by the amazing Denny O'Neil, Bane first appeared in the appropriately titled story Batman Vengeance of Bane #1 in 1993. 1993 was a very busy year indeed for Bane, as later that year was when the Nightfall story arc began. The story which sees Bane break Batman's back, as shown here on the cover, something which was later recapitulated in Christopher Nolan's The Dark Knight Rises.
I was wondering what would break first. Your spirit? Oh, your body!
Nolan's Bane is quite different from the Bane of the comic books, taking on a much more realistic tone, but that is the case for all of those movies, and so he will not really be the focus of this lecture here. Comic book Bane, however, was born on the island of Santa Prisca within the prison Pena Dura, destined to serve a life sentence for crimes committed by his father. Seems a little unfair, if you ask me. But over time, he became the so-called king of the prison. But this ended up being much more of a curse than it was a boon, because the prison wardens began to focus harder on him, selecting him to undergo experimentation with their synthetic compound, Venom, in an attempt to produce super soldiers. Venom is a synthetic compound that aims to dramatically improve the user's strength. However, it is known to be highly addictive. The chemical makeup of Venom is seemingly unknown from my own personal research, but if you do know better, then please don't hesitate to leave a comment. What we do know is that it is a derivative of Rex Tyler's, aka Hourman's, Miraclo drug, which grants him his short-lived superhuman abilities. Rex did not want the formula of this compound to get into more dangerous hands, thus he attempted to destroy all known copies, but leaving the only information found in his brain. However, it wouldn't be a very good comic book story if that is indeed what happened, and the Bane Pharmaceuticals company found the formula and modified it into Venom. Here we have the Arkham Asylum Venom, one of my favourite designs, but I know people don't necessarily agree with that. But in this case, the Venom is stored on the back of Bane in this tank and pumped through these pipes directly into his body. Whereas, of course, Rex Tyler had it much easier, could just take a little tablet. In 1998's Batman and Robin, however, the origins of Venom are much more understood, as it was indeed just that, a snake venom used by Pamela Isley to improve her plants. And it was also what was involved in transforming her into Poison Ivy. So in that film, Bane and Poison Ivy share a similar origin. So we may not know what is in Venom, but it is clear that it is some sort of anabolic steroid. Anabolic steroids are synthetic derivatives of the hormone testosterone that can come in one of two classes: 17 alpha alkyl derivatives and 17 beta ester derivatives. We'll get into what those are shortly. But before we get too deep into steroids and their effects, we should briefly touch on what testosterone, natural testosterone, is and what it does. So we start with the hormone GnRH, and that's produced by the hypothalamus in the brain. This stimulates the anterior pituitary gland, also in the brain, to produce two hormones: luteinizing hormone and follicle stimulating hormone. The latter, in males at least, is involved in the production of sperm, so that's spermatogenesis, in the testes via Sertoli cells. But luteinizing hormone stimulates Leydig cells, which are what produce testosterone. The hormone is produced and it can either be reduced into DHT, that is dihydrotestosterone, or it can be converted into estradiol by the enzyme aromatase, estradiol more commonly known as estrogen. Like all hormone production cascades, they are controlled by negative feedback loops, so high concentrations of testosterone are inhibitory to further production of GnRH, FSH, and luteinizing hormone. So that will prevent the just continuous production of testosterone. Like a lot of hormones, receptors for the androgen hormones like testosterone can be found in a lot of tissues throughout the body, and therefore their effects are extremely wide-ranging. There is an extremely high concentration of these receptors found in bone tissue, which is what this figure is trying to represent here, namely osteoblasts and osteoclasts, as well as chondrocytes, which are involved in the production of cartilage. But more specifically, these receptors are alpha and beta estradiol receptors, and as we just mentioned, estradiol is derived from testosterone. These receptors downregulate bone reabsorption and increase bone mineral densities. Osteoblasts are the bone producing cells, so there is a greater concentration here. Though there is some on osteoclasts to inhibit bone destruction, which is what those cells do. Relatedly, increased androgen levels increase the levels of lean muscle and decrease the levels of body fat. The last thing I wish to touch on is the positive effects testosterone can have on mental health, an ever-increasing issue in our current world. Those with hypogonadism, so with smaller, less developed sexual organs, and thus have lower levels of testosterone when compared to age-matched healthy males, show an improved mental health when administered with androgen-containing supplements. So in individuals such as this, they show a reduced likelihood of suicidal ideation and self-harm, and indeed supplementation appears to have a positive correlation with the more positive mood aspects such as friendliness and general positivity, which is what these figures show here. And on this side we have a decrease in those negative mood traits such as irritability. However, it is crucial to add that there have also been many studies that show the opposite, that testosterone supplementation in those individuals with hypogonadism have increased physical and mental aggression towards others, and this highlights why you can never just rely on one data set from a small sample, and why literature reviews are so important. As I was saying earlier, anabolic steroids come mostly in one of two flavours, those which have an additional alkyl group at carbon 17, so carbon 17 is here, and these are a range of alkyl groups, and these are normally oral steroids, and those which undergo esterification at carbon 17, so this is an ester group here. These drugs are more effective, but they do have a shorter half-life and require intramuscular injection to be administered. Nandrolone derivatives are arguably the most famous of these, being some of the first anabolic steroids used by athletes in the 1960s, and therefore subsequently banned by the International Olympics Committee in 1974. This is nandrolone decanoate here. You can see the ester group. The decanoate comes from the 10 carbons here, and this is nandrolone phenyl propionate. You can see again, here's the ester group. You know it's a phenyl because the phenol group involves this benzene ring. And they both increase the rate of anabolic activity, that is the process of constructing larger molecules from smaller ones. And they do so in a similar way, although the mechanisms are ever so slightly distinct. But ultimately, they both lead to an increase in amino acids, which are necessary for protein construction and therefore muscle mass. The former, decanoate, involves increasing the retention of nitrogen, whereas the latter increases appetite and the rate of muscle growth. Another anabolic steroid is dromasterone, a drug that's 5 times more potent than natural DHT. Again, you can see the ester group here. This too has a similar mechanism of function, increasing the retention of nitrogen, phosphorus and potassium. So nitrogen is a constituent of amino acids, phosphorus is needed for a lot of enzymatic reactions to occur, and potassium ions are needed to help maintain ribosome function, which is necessary to produce proteins. Ergo, by taking dromasterone, you are dramatically increasing protein anabolism, decreasing protein catabolism, the destruction of protein, and therefore increasing muscle mass, muscle density, and muscle hardness. These synthetic testosterones can also increase muscle mass by increasing the levels of the hormone IGF-1, which itself stimulates muscle growth and is especially important during puberty. However, taking anabolic steroids can also negatively impact other hormones. So a class of steroid hormone, which is the same type of hormone as testosterone, are the glucocorticoids, and the most famous of these is probably the stress hormone cortisol. So because they have similar structures, the anabolic steroids can displace the glucocorticoids from their receptors when significantly above physiological levels, and therefore acting as competitive inhibitors. So here we have just a general figure of what competitive inhibition is. So this is your normal substrate enzyme binding. So you can imagine the enzyme here being the receptor instead, and your substrate being the glucocorticoids. This glucocorticoid fits perfectly in the receptor substrate. However, the competitive inhibitor, in this case the anabolic steroid, with its similar structure, can also fit into the receptor binding site, preventing the glucocorticoid from interacting. Ultimately, this is beneficial for the steroid user as it acts to decrease protein breakdown and therefore increase muscle mass, which is of course the most obvious reason as to why people take these anabolic steroids. Furthermore, as highlighted by the introduction, the production of hormones is regulated by negative feedback loops, and if you are synthetically increasing your levels of testosterone, you are leaving on this negative feedback, preventing stimulation of the hypothalamus and the anterior pituitary gland. This will ultimately lead to the user becoming infertile because you're lacking the production of follicle stimulating hormone, the FSH, on the Sertoli cells, and therefore preventing spermatogenesis. We've discussed a couple of times in these lectures the damage reactive oxygen species and oxidative stress can have on cells, and perhaps this is the true through line of Science After Hours. And indeed, anabolic steroid abuse can disrupt the electron transport chain in mitochondria by disrupting mitochondrial calcium ions. With an imbalance of calcium, the mitochondria is not functioning optimally, leading to an increase in reactive oxygen species levels. This is also not including the hepatic and nephrotic damage caused by taking anabolic steroids, the two organ systems that are crucial for reactive oxygen species metabolism and excretion. The increase in reactive oxygen species is associated with an increased risk of cancer, but it is also associated with neurotoxicity or premature apoptosis, controlled cell death of neurons, and this will cause dementia and the behavioural changes associated with roid rage. The cardiovascular system is also particularly susceptible to oxidative damage, and taking anabolic steroids also increases the circulating levels of TNF alpha, a pro-inflammatory modulator that can inadvertently cause heart damage if levels are not kept in check. They also increase the levels of low-density lipoproteins and their deposits in blood vessels, a process which you might know by the name of atherosclerosis. And anabolic steroids can cause irregular heartbeats, so it's therefore quite unsurprising those who take anabolic steroids are more at risk of heart attacks. So in the case of Bane, I wouldn't worry too much if Batman can't eventually stop him, because ultimately either a heart attack or dementia will. Thank you very much for watching.